Okay, what we will need for this video lesson is our pink calculator tips sheet, our video lesson worksheet, and our calculator. You should also try to have your lesson notes from today's class nearby. This chart from today's packet will be very useful when we're trying to classify whether a relationship is strong, moderate, or weak. We can refer back to these table of values to help decide. Okay, so when we get started, we see that the first question wants us to find the correlation coefficient using our calculator. So to do that, we need to first figure out what is it that I need to enter into the calculator. So if you see that we have two variables here, on my x-axis, I have the number of hours students spend studying. This would be my first variable. Now we're introducing a second variable. We're trying to see, does the amount of time spent studying affect our region score, which we have plotted on the y-axis. So each student surveyed was asked, how many hours did you spend studying, and what was your resulting region score? So someone who studied 3 hours scored an 80. Someone else studied 5 hours, scored a 90, and so on, all throughout the table. After plotting all of these values, we see that this is not a perfect relationship because we learned today in class that a perfect relationship would look like a straight line that passes through every single point on the scatter plot. But we can see clearly that that is not going to happen here. So to determine how strong, moderate, or weak the relationship is, we need to determine the correlation coefficient, and the calculator will do that for us. Instead of entering these values in as x and y values, we use the stat menu in our calculator, and we're going to use the x values for list 1 and the y values for list 2. So right now, please turn on your calculator. Okay, I have my calculator here. We want to go to the stat button. And if we go to our pink sheet though, it tells us to check if something is turned on first. Right here on your pink sheet, it says that we have to make sure our diagnostics are turned on. So that's actually something I have to do before I even edit the information. So let's go back to the home screen so that we're all starting in the same place. To turn on your diagnostics, you have to hit the second button and then the 0. It will take you to the catalog. Now we can choose to scroll down until we find the choice that says Diagnostic On, or I can hit this button here that says X to the -1, and it'll start me right off at the first D option, so I don't have to click the down arrow too long. And now I'm going to keep scrolling down until I see Diagnostic On. I want to turn the diagnostic setting on. So when this arrow is in front of it, you hit Enter, and hit enter once more, and it should say done. Now our diagnostics are turned on. Now that we've done this, we can enter our data values into the calculator. So let's do the same way we have in class. You go to Stat, we want to hit enter for edit, and my list 1 is already empty. If yours still has data values in it, remember you can go up to the top, hit clear, and then enter, and it'll bring you back here and it will be emptied out. All right, so we're going to enter our study hours in for our x-axis, or our list 1 rather. So I'm going to keep going, and after I finish typing in these study hours, I am going to hit the right arrow key and type in all of the region scores. Now it's very important that you line up the correct values. So I do not want to type these in just any order. This person who studied for 3 hours must be paired with their own score of an 80. The person who studied 5 hours must be paired with their score of a 90, and so on. So be careful when you enter the data when you have two lists being compared, two variables. Okay, now that we have all of the data entered, we're going to go back to Stat, And as we've done in the past, we're going to go over to calculate. Remember, if you get lost on any of these steps, every button and every screen is printed on your pink sheet. Okay, so back to the calculator. We have Stat. We're in the Calculate menu. We're going to use something new today, Choice 4. So I'm going to scroll down to Choice 4 and hit Enter. If I hit Enter once more, these values all show up. Our R value is the one we're interested in. It says R is equal to this long decimal. So I'm going to copy that onto my page. But here above, it says we're allowed to round to the nearest hundredth. 100 has 2 zeros in it, so that means I need 2 decimal places, 2 digits after the decimal. This 4 tells me to keep the 5 the same, so R is approximately 0.85. Before we move on to the next problem, let's see what this value truly means. So if we think back to our notes from today's class, 0.85 falls in between this range, and it is positive, so it indicates that there must be a strong positive relationship between these two variables. There is a strong positive relationship between the time spent studying and Regent scores, which should make sense. We always hope that there is causation in this case. We hope that if we increase the number of hours we spend studying, that it will increase our Regent score. Okay, let's find one more correlation coefficient together. This time, our list 1, or our x-axis, is showing us the number of jars of jam that are being sold in New York over the course of a week, and the y value is showing, or our list 2 value, is showing the number of CDs that are sold in Florida during that same time frame. Now, seem kind of ridiculous that these would be related, but it appears that there's something or a trend here. So let's see how strong, moderate, or weak it would be classified according to its correlation coefficient. First, we need to go to our calculator, and because we've already turned on our diagnostics, we do not have to do that again. So we're going to Stat, we want to go to Edit, and just want to go up to the top, clear Enter, and up to the top, clear Enter, and we're going to type in all of these data values. So I'm going to type these in as you do as well. Pause the video, and when you play, they will all appear. Okay, so hopefully you've typed in your data values, and now at this point, we go back to Stat, we go over to Calculate, and we scroll down to Choice 4 again, 1, 2, 3, down to 4, hit Enter, Enter, and we record this R value. So I'm going to record this R value on my paper. And then I check to see what I'm supposed to round to. It says to the nearest hundredth, so I'm going to do that now. We want to look at these two digits. The 3 tells me to keep them the same, so I like to input that 0 in front. It's not required, but it's approximately 0.96. Now this value, if we use our chart from today's class, is not perfect, but it's pretty strong. It's pretty close. So here, it seems that there's a very strong positive relationship between the number of jars of strawberry jam that are sold in New York during the same week that CDs are sold in Florida. However, just because there's an increase in both does not necessarily mean that there is causation. The number of jars of jam being sold in New York does not cause the number of CDs to increase in sales in Florida. At this point, I'd like you to pause the video here, try problems 3 and 4 on your own, and then press play to check your answers. As we see here, we're comparing the number of hours in a mall and the number of dollars spent, there appears to be a weak negative relationship between the two. According to our table, that negative 0.26 would fall right in between this 0 and negative 0.3. So we would describe it as a weak negative relationship. When it's negative, it indicates that as one variable is increasing, the other is decreasing. Okay. Again, if you haven't tried this one just yet, please pause the video, give yourself a chance to try it on your own, and then press play to check. In problem 4, a nutritionist collected information about the number of calories and the number of milligrams of sodium in beef hot dogs, and she made a table and found that there is a strong positive relationship between the two. This value of 0.94 represents our correlation coefficient. It's a strong positive relationship. As the calories increase, the sodium increases. This could possibly be a causation relationship, although, again, I'm not a nutritionist, and I'm sure there are other contributing factors that may include the increase or cause the increase in sodium, rather. So today's lesson, after we were finished, we were able to use this correlation coefficient value to describe the strength between two different variables and their relationship. We were able to use our calculator to find the correlation coefficient.